Fitness for service, FFS, assessment in a petroleum refinery refers to the assessment of the structural integrity and operational reliability of equipment and facilities used in the processing of crude oil and its derivatives. This comprehensive evaluation ensures that equipment such as pressure vessels, piping, storage tanks, and other critical components remain safe and operational throughout their intended service life. FFS assessment is crucial in maintaining the integrity of refinery assets, preventing catastrophic failures, and optimizing operational efficiency. As vessels, piping, and tankage endure service over time, they undergo various forms of deterioration or harm that could compromise their structural integrity. To assess this integrity and prolong the safe operation of damaged equipment, an engineering evaluation or fitness for service, FFS, assessment becomes necessary. Many design codes and standards for pressure-containing equipment inadequately address degradation and damage during operation. In industries such as pressure vessel and pipeline, surface flaws significantly limit the lifespan of vessels or pipes. This degradation, stemming from aging and aggressive environmental factors, eventually jeopardizes the structural integrity of the equipment. Replacing vessel and piping equipment is costly. Thus, it's more economical and preferable to continue operating slightly damaged equipment. However, for corrosion beyond a specified limit or other damage mechanisms like cracking, an FFS assessment is essential. FFS assessments are quantitative engineering evaluations conducted to prove the structural integrity of an in-service component with flaws or damages. The American Petroleum Institute, API, has developed Recommended Practice, RP 579, a comprehensive document offering guidance for conducting FFS assessments, particularly for flaws common in the refining and petrochemical industry, affecting pressure vessels, piping, and tankage. Nevertheless, these assessment procedures can also be applied to various types of flaws and damages encountered in other industries like pulp and paper, fossil fuel utilities, and nuclear sectors. The guidelines outlined in API 579 assist in making decisions regarding running, repairing, or replacing equipment to ensure the safe operation of pressurized equipment identified with flaws during inspection. API 579 furnishes guidelines for conducting FFS assessments that can complement API inspection codes, API 510, API 570, and API 653, to ascertain the suitability for continued operation. These assessment procedures can be utilized for FFS assessments and/or re-rating of components designed and constructed according to various codes. API inspection codes, API 510, API 570, and API 653, to ascertain the suitability for continued operation. These assessment procedures can be utilized for FFS assessments and/or re-rating of components designed and constructed according to various codes such as ASME-B and PV Code, Section 8, Division 1, ASME-B and PV Code, Section 8, Division 2, ASME-B and PV Code, Section I, ASME-B 31.3 Piping Code, ASME-B 31.1 Piping Code, API 650, API 620. API 579 serves as a complement to an enhancement of the stipulations outlined in the inspection codes API 510, API 570, and API 653. Its objectives include maintaining an adequate safety margin, offering precise predictions of remaining equipment life, and aiding in the optimization of maintenance and inspection procedures for equipment that is still operational despite being damaged. The pressurized equipment under consideration may harbor flaws and damages, deviate from present design standards, or face more severe operating conditions than originally intended or currently recognized. The outcome of an FFS assessment typically leads to a decision on whether to continue operating the equipment as is, modify it, conduct repairs, implement monitoring measures, or opt for replacement. FFS assessments consist of analytical methods to assess flaws and damage and usually require an interdisciplinary approach consisting of the following: knowledge of damage mechanisms, material behavior, knowledge of past and future operating conditions and interaction with operations personnel, NDE, flaw location and sizing, material properties, environmental effects, stress analysis, often finite element analysis, data analysis, engineering reliability models. Assessment methodology: the API 579 FFS assessment method used for all damage types including brittle fracture, general metal loss, local metal loss, pitting corrosion, blisters and laminations, weld misalignment and shell distortions, crack-like flaws, high temperature operation, creep fire damage. API 579 is a highly structured document designed to facilitate use by practitioners and to facilitate future enhancements and modifications including applicability and limitations of the FFS assessment procedures, data requirements, assessment techniques and acceptance criteria, remaining life evaluation, remediation, in-service monitoring, flaw and damage mechanism identification, applicability and limitations of the FFS assessment procedure. The API 579 FFS assessment approach: each section of API 579 that addresses assessment procedures is structured in accordance with this methodology. This uniform treatment of damage and the corresponding FFS assessment procedures streamlines the document's usability. If a user is acquainted with one section of the document, navigating another section is straightforward due to the shared structure. This assessment methodology has demonstrated resilience across all types of flaws and damages included in API 579. API 579 outlines 3 levels of assessment for each type of flaw and damage. Overall, each level of assessment strikes a balance between conservatism, the extent of information needed for evaluation, the proficiency of the practitioner conducting the assessment, and the complexity of the analysis being executed. Level 1 represents the most conservative approach but is also the simplest to employ. Practitioners typically progress sequentially from Level 1 to Level 3 assessments, unless directed otherwise by assessment techniques, if the current level fails to yield satisfactory results or if a clear course of action cannot be discerned. Level 1. This level furnishes conservative screening criteria designed for use with minimal inspection or component data. Plant inspection or engineering personnel may utilize Level 1 assessment procedures. Level 2. Here, the assessment procedures aim to deliver a more intricate evaluation, generating results less conservative than those of Level 1 assessments. Similar to Level 1, Level 2 assessments necessitate inspection information, but they entail more detailed calculations. Plant engineers or engineering specialists with experience in FFS assessments typically conduct Level 2 assessments. Level 3. This level is geared toward providing the most detailed evaluation, yielding results less conservative than those obtained from Level 2 assessments. Level 3 assessments typically require the most comprehensive inspection and component data, and the recommended analysis relies on numerical techniques such as the finite element method. Engineering specialists adept in FFS evaluations primarily undertake Level 3 assessment procedures. Determining equipment remaining life and rating. API 579's FFS assessment procedures address both the current integrity of a component given its existing state of damage and the anticipated remaining lifespan. Should the results of an FFS assessment affirm the equipment's compatibility with prevailing operating conditions, it can continue operating under these conditions provided a suitable inspection regimen is implemented. In cases where the FFS assessment indicates that the equipment is unsuitable for current operating conditions, API 579 provides calculation methodologies for rating the component. Alternatively, the remaining life calculation is utilized to establish an appropriate inspection frequency in conjunction with the relevant inspection code and/or in-service monitoring plan, or to determine the necessity for remedial action. Concluding remarks. Fitness for service (FFS) assessments serve as quantitative engineering evaluations conducted to validate the structural integrity of in-service components harboring flaws or damages. API 579 serves as a guiding document tailored for conducting FFS assessments within the refining and petrochemical sector. However, the methodology outlined in API 579 is not limited to these industries alone. It can also be effectively applied to flaws encountered in other sectors such as pulp and paper, fossil fuel utilities, and nuclear industries. The recommendations set forth in this practice aid in making informed decisions regarding the operation, repair, or replacement of pressurized equipment identified with flaws during inspection, ensuring their continued safe operation. Thank you very much for watching the video. You may consider to subscribe, like, sharing or pressing bell icon for this video, if it is worth doing. Explore our YouTube channel, PetroCelt, for captivating videos covering science, engineering, technology, and energy topics. The primary aim of launching this YouTube channel is to facilitate the exchange and dissemination of knowledge and experiences among professionals and amateur